Welcome everyone. The first chapter for electrical machines and drives is AC motors. These are all the things we are going to discuss in the first chapter. So, what do you mean by electrical motor? What do you mean by electrical motor? Electrical motor is one which converts the electrical energy into mechanical energy. The electrical motor is one which converts the electrical energy into mechanical energy. So mechanical energy, what are all the applications of mechanical energy? For operating the fan, for rotating a impeller, for rotating a compressor, for lifting the materials from one place to another place. These are all the applications of the electrical motor. And most of the industry, wherever we are going in process industry like pharmaceutical industry, chemical industry, petroleum refinery industry, in marine places, everywhere we are coming across this electrical motor day to day life. Next thing, how does an electrical motor work? How does an electrical motor work? Okay, so it works with the principle of Fleming's left hand thumb rule. It works with the principle of Fleming's left hand thumb rule, as well as by the Faraday's law of electromagnetic induction. So the principle of operation of the electrical motor, is basically when a conductor, current carrying conductor is placed under a magnetic field, this conductor will experience a force. That is the principle of operation of a motor. Okay, so for example, this is the first picture. Second picture, it shows here in the middle we are having the rotating part, and now N and S, this is the north pole and south pole of the magnet. So what will happen from north pole to south pole? The magnetic flux are traveling, and what we are going to do means we are going to pass the current in this rotating part. By means of giving a supply, DC supply. So this will move towards this arm in this rotating part, and when the current carrying conductor is placed under a magnetic field, this conductor will experience a force. That force is called as the torque. Torque is nothing but the rotating action. Torque is equal to force multiply 2 pi r. That is the circumference of the rotor, the circle. So force is the linear action, torque is the rotating action. The twisting moment of a particle with respect to any axis is said to be torque. So this is how the electrical motor is working, which converts the electrical energy into mechanical energy. Okay, and normally the classification of motors, we can make it as like this. So electric motors, it is divided into two parts: alternating current motors, AC motors, and DC motors. AC motors, there are two types. One thing is synchronous motor and induction motor. Okay, synchronous motor and induction motor. And in the induction motor we are having two types: single phase and three phase. So this DC motors which works with DC supply, and AC motor which works with an AC supply. So these are all the classification of electrical motors. Okay, then this is the normal picture of a electrical motor. You can, if you go to any industry or any working place, you can see the nameplate details of the motor. If you go here, it shows this nameplate details. It shows the rated voltage, the rated current, what type of motor it is, whether it is single phase or three phase, the power which is written is HP or kilowatt, horsepower or kilowatt, and the RPM and frequency, and then the power factor. So you can get all the information from this, the nameplate details. From this, the nameplate details. So we are going to see the construction of the electrical motor. Here we will be seeing the parts of the motor. So the parts of the motor, there are two main parts. First one is called as stator. Stator is nothing but the stationary part. Stator is nothing but the stationary part. Maybe the stator is nothing but the stationary part. In that stationary part, we are going to fix the magnetic poles. The stator will be having the magnetic poles, and the stator is in the outside of the stator is the outside part of the motor, which governs the machine. So stator will be having the magnetic poles. In the magnetic poles, there will be the magnetic flux lines are traveling. It shows the magnetic flux lines. Okay, this is the stator. And the next part is called as the rotor. The next part is called as the rotor. Rotor is nothing but the rotating part of the motor, and further which is governed by the yoke. Yoke is the which governs the whole setup, stator and rotor. And from the rotor, there will be bearings to avoid the friction losses. Then there will be a fan to provide the cooling for the current carrying coils. This is the important parts of AC motor. Important parts of AC motor. The next is the stator consists of two parts. Stator, which is the stationary part of the motor. Rotor is the rotating part of the motor. And then the detailed parts of the AC motor, I show everything already, we have discussed. So this is the end seal, bearings, it is for using the avoid the friction, and the rotor is the rotating part. Here we are having the field poles. Field poles will be having field windings, and then this is the outer frame. Then there will be a fan. So main two parts are stator and rotor. Okay. Now, what do you mean by stator? Stator induction motor works with the principle of transforming action. That is, the stator works as the primary and the rotor works as the secondary. Okay, so the induction motor is called as rotating transformer. It is also called as asynchronous motor, as well as it is also called as rotating transformer. Then regarding the stator, stator will be having the slots. Slots means the gaps. Stator will be having the gaps. Okay, and there will be arrangement is like this. The stator will be having the slots. In the slots only we are going to keep the field winding, and there will be tooths. This is the outer frame of the cover. Okay, so we can see here the stator. As I told you, these are all the slots. These are all this one and this one are the slots, and this is the outer core, and this black color wire, this is the winding. So this is For the stator winding. See, stator winding is made like this in the industry. So the stator has three main parts. One is stator outer frame. This is the outer body of the cover, which protects the machine from any mechanical injury, and it provides the magnetic flux to travel in that outer frame. And the second part is the stator core. Stator core is made up of high-grade silicon steel. High-grade silicon steel is the which is having very less resistivity for the magnetic flux. It will allow more magnetic flux to travel, and finally we will be having the stator winding, which is having a three-phase winding or a single phase winding. So this is for stator, and the next video we will discuss about